Hello and welcome to Identirati Office Hours. I'm your host, Mike Schwartz, founder of Glue, and today is episode 102, and the topic is the rise of embeddable PDPs. And a quick reminder, if you like the live stream and you want to support us, please follow us on LinkedIn. There's a LinkedIn company page for Identirati Office Hours. And our guest today is a returning Identirati, Alex Olivier. Welcome, Alex.
Hey, Mike. Thanks for having me back again. And it was great to see you last week at IIW as well.
Yes, we got to meet in person again at IIW. And as our audience will surely remember, Alex is the CTO and co-founder of Cerbos. And he was a guest on episode 73, The Future of Auth from A to Z. So we're going to skip the introduction this week, but if you want to know Alex's journey of how he became CTO and co-founder of an authorization company, check out episode 73. And so this week, I'm actually going to start it off. This is sort of a collaborative episode because we have Alex and I are doing a session at Identiverse in June on this very topic.
Indeed, it's a bit of a practice run.
And this is, yes, a practice run. In the actual session, we only have 20 minutes, whereas on this session, we have about 40 minutes. So we will edit it down. The final one will be so much better. You definitely want to be there. But let me just start with a definition of embeddable PDPs, so I can see if Alex and I are on the same page. We haven't hashed this yet together to see if we agree. So my definition of an embeddable PDP is a PDP that the developer loads into their runtime and uses kind of like a library. So they initialize it and they call it like a normal method, and they sort of build their program around it. And that's my very technical definition. Alex, do you have any qualifications
Yeah, I
on
mean,
that?
absolutely. I think the developer experience kind of is key here. And it's not just how you integrate it, but also what other like infrastructural things do you need to spin up and run in order to do authorization. There's the approach where you basically run another service, another microservice alongside your infrastructure. And that takes overhead, that takes thinking about deployments, takes time in terms of setup. Whilst the embedded version is just, like you said, another asset, another library that's inside your code base and essentially is running in process without any other external sort of dependencies at that point. We'd say kind of the two ways we see the world.
So I'm cracking up. My cat is like attacking me. So I think she sees the Cerbos dog and she's terrified.
There we go.
Okay. So, right. So an embeddable, right. Everybody knows OPA at this point, Open Policy Agent with 10 million downloads. That runs as a sidecar. So it's like a whole nother Linux container operating system running locally next to the application. But that deployment model is not ideal. There's a certain amount of overhead just to make that. When you have like the sidecar like that, you normally have a JSON REST API that involves some overhead, and you have to spool up that container, and that's not going to happen in something like a web application or a mobile application. You can't run a sidecar. So I guess I just see embeddable as an approach that's maybe throws a wider net for the types of applications that it can support.
Yeah, I mean, the use cases for embeddable PDP. So with Cerbos, we have both. We have one that is that container, that service that's running and deployed somewhere. And then we also have a build that basically takes your policy and compiles it down to an embeddable version. The key technology here, which we'll talk about in a bit, is WebAssembly. And that basically gives you a runtime which you can pull in and run in different environments. And really like the drivers for why and we ended up going down the route of creating an embeddable PDP and kind of the use cases we're hearing for the desire to have this approach is initially around how can we do more like presentational type permissions? Like, should this user be able to see this menu item? Should these options be enabled? Should this navigation link be visible based on that user's or that subject's role or various attributes? And in those cases, making a whole separate REST API call, like you said, that JSON API to your backend, and then that backend calling out to another service, is lots of hops for things that are merely presentational at this point. If you're thinking about on clients in terms of mobile apps or in browser. So basically having this sort of hybrid approach where you have some things running and checking on a backend, on a service, a proper service, and then an internal or a local embedded decision point allows you to make those very quick, more sort of presentational type permission checks at the UI layer. But we're now seeing as kind of the ecosystem of technology evolves, it being adopted at different points in the stack, at edge and different kind of worker type environments as well that can utilize that same concept. So it basically allows you to bring authorization to where it needs to be in your stack.
Right. And there could be hundreds of decisions a page might need to evaluate to render properly the content. So my thought was on this in this format, we might structure the conversation by thinking of like three pros for embeddable PDPs and three cons for embeddable PDPs. And maybe let's start. We're talking about the pros, so maybe we should start with the pros. And the first one I think you alluded to already, but maybe we could flesh it out a little bit more. And that's speed or latency, or the lack of latency in an embeddable PDP.
Yeah, if you think of things around like network hops, and every hop between service or node or cluster is going to take a hit, and sometimes that is just not really an option. Authorization is in the critical path of every request. Everything from how fast the page feels in terms of evaluating which components to show based on policy. If you are making a network request every time, obviously you can batch them and things. You're either going to be sending lots of requests or very large requests, and that overhead is going to take a hit at some point. And ultimately, there's going to be a connection open somewhere. You need to keep it alive, so you need to have CPU cycles handling it, etc. So the advantage of the embedded approach is you remove that completely. Once the embedded PDP comes down is instantiated on whatever client you're using, be it a web browser, mobile app, some edge function, or whatever, that's it. There's no further network involved. So you are getting what feels like calling a library. It is just like calling a method that is native to your application at that point. What happens behind that method call is kind of, as a developer, you don't need to worry about. Behind it, there's an engine that's evaluating policies, but you're just calling a method and you're getting, depending on how you architect it, a probably synchronous response without having to worry about network calls and network hops through your architecture and your infrastructure to get a decision.
Do you time those? How long authorization requests take in the Cerbos? Is it called ePDP?
Yeah, there are better PDP. It's a tricky one to benchmark because everyone's browser environment is different. Everyone's mobile device is different. Every edge worker environment is somewhat different. A lot of the time, if you kind of profile it, you're busy trying to marshal JSON backwards and forwards and trying to pass that. That's where a lot of the time goes. That's kind of the beast that we've built ourselves, I guess, with JSON particularly being the main mechanism, but there's other ways around it. The actual decisions, though, are going to be much more tied to the complexity of your policies at that point, more than anything else.
But you're talking about sub-millisecond.
Oh, 100%. Yeah. You're
Yeah.
talking nanoseconds, really, at this point.
Yeah. So, yeah, I agree with that. I'll just add a couple of other observations. As soon as you hit the network, you're talking about a couple of milliseconds. Like even on a really fast local network, you're talking about milliseconds. And the other point I'll make out, which is sort of adjacent to latency, is reliability and robustness. So in a true microservices environment, you don't want any external dependencies. So as soon as you make that network connection, well, it might, the switch might be down and it might not connect. So you have a less robust system when you make that network call. So I think that's important for applications where previously they'd been implementing RBAC and there was no such, they could implement their own rules in their application. Now we're saying, well, RBAC's not good enough. We need to have more complex policies. Therefore, we need some type of policy engine. And so instead of saying, well, this policy engine it needs to run on the network because it's so complicated and it's so big, you're going to have to make a network call to it. We're saying, okay, we can put that in your application, that engine, and that way you won't have the risk that the connection will fail and the latency associated with that. Yeah.
Yeah, it removes all those discussions and thought processes around like how does the decision point scale? Is it horizontally scaling, vertically scaling? What's your redundancy? All those problems go away if it's literally embedded in the process.
So yeah, I think hopefully everyone can see how much faster this is and how that would improve UX. So my next for embeddable PDPs is that maybe it's not a for, but a reason why we could do it now and we couldn't do it in the past has to do with a technology called WASM or WebAssembly, which for those of you who don't know, because it can be thought of as a front end technology, although it's now used extensively also for back end serverless. But WASM is like it's like a runtime evaluation engine, almost like the Java runtime engine or the JavaScript engine that runs in the browser. But it's an engine that I guess where the interfaces have been agreed on by the browser vendors. So multiple browser vendors implement the WASM engine. And the nice thing about the WASM engine is that you can write code in Go, Rust, or other languages that compile into WASM, which enables you to write much faster components than we could in the past. And in fact, if any of you are into gaming out there, a lot of the advanced graphics processing now happens in WASM because they have just more speed to do graphics processing in the WASM engine than in JavaScript. So WASM, I believe, is one of the enabling technologies that enabled us to take this big, complicated PDP and actually put it in the browser. I know, Alex, maybe you have more WASM knowledge than I have, but any thoughts on
Oh,
that
I want to
topic?
go that far. I've heard lots of analogies for WASM and sort of what it's like, and some say it sort of harpers back to the days of ActiveX or Flash kind of components inside of applications. It is essentially that runtime, but in this case, the engine is embedded into the browsers or the V8 framework or these kind of different ecosystems. So you can stick to writing Rust or Go or JavaScript even, and then you compile it down to a WASM module, which is mostly standalone now. You don't need to ship both the application code and the runtime. The runtimes already exist in these environments. So you bring in the WASM module. It can be a asset that's inside your code base. You can stream it in from some endpoint.
Right, like NPM, for example, which all the JavaScripts use, you can actually publish your WASM through NPM, so it looks like any other JavaScript library.
Yeah. A lot of the tool chain now is in the JavaScript ecosystem is moving to Rust, and a lot of that's being compiled down to WASM to actually run on local devices. But once that module is pulled in from whatever source, you just instantiate that module, and then it exposes its functions basically. Be it simple, there's a very popular WASM module around like cryptography, and we're implementing some of the crypto algorithms directly in WASM, so you can do it everywhere, and it basically exposes the methods for signing, verifying tokens and other kind of assets using the native code without having it to be re-implemented inside of, say, JavaScript, because you avoid a whole load of problem and testing overhead rather than having to re-implement your code. You stick with your C or your Rust or your Go, and then you build this asset that can run anywhere. So it really is that write once, run anywhere dream that many of us were sold in previous technologies, coming a bit more to fruition
Java
now.
in 1995, yeah.
Yeah, sorry, I was 4 years old in '95. I wasn't quite worrying about Java yet.
Yeah, I actually remember
Yeah.
writing. Was this 95? Yeah, 95. I started programming in Java before jar files. You know how bad it was before you could actually like put together libraries. Um,
I'm
but the
sure.
dream was very much with Java that we could run it in the browser. There was applets, and so that was very much the dream. And so we are 30 years later or so. And but talking about
Mad, isn't it?
but WASM actually seems to work, so that's a big difference. And Java is now pretty much exclusively server side, I would say, because it's big and takes a lot of memory. Whereas
Yeah.
Rust or Go, these WASM modules are really pretty compact. I don't know how big is the ePDP binary. Are we talking it's tens of megabytes or
Oh,
megabytes or
not even
what's the
that.
size?
I mean, it's linear with the number of policies you have because we kind of bake them in there. But
Yeah.
you're talking a pretty small amount at that stage. Let me just check one quickly. Yeah, you're talking a couple of 100K
Okay.
in kind of the basic scenario, and that is the like
Yeah.
runtime and the policies at that
That's
point.
really good. We're still we're like under 2 megs, so like a meg and a half or something. But yeah, but that's really small if you're at a couple 100K. That's a lot of business logic. It's just very, very compact and very
Mhm.
fast, and that's good for a policy engine because we don't really. We said speed is hyper important here. Um,
Speeds up performance, and one of the other big advantages of WASM now is there's really this growing ecosystem around it. So WASM WASM components is a thing. So you can actually compose together different WASM modules to build kind of different components. So you could go and plug in an HTTP server or a gRPC interface or a standard IO type interface and plug it into your policy engine. And so you can actually start adapting and composing these modules together as long as they expose kind of a common interface, which allows you to start pushing these engines and these runtimes into completely different architectures or environments where previously it would have been impossible to, take that Java servlet and run it in an environment that doesn't have Java, for example. So you get this really nice composability element with the whole WebAssembly ecosystem, and have that
and you're
true
talking
write
about
once, run everywhere.
like taking your WASM module and deploying it in the cloud as a serverless function, something like that.
So where you run it, I think is kind of where a lot of the advantages come. So you can go and run it in a browser, you can run it in a iOS app, you can run it in an Android app, or you can go run it in a Cloudflare worker. Is kind of the common one we see a lot. But the WASM ecosystem as well. There's this WASM sort of component library standard out there now where you say would take your Cedarling engine, you would define what interface it has, so the typical principal subject action resource type interface, and it returns an allow or deny decision. And then you could go and take someone else's, say, HTTP library and stick it in front of that, and then that would expose an HTTP interface to that system. But equally, you might have one that wants to work over sockets, let's say straight sockets. So you can have a socket adapter on top, and these things can be composable. So you can focus, someone building like a WASM module can focus on what that your core module does. You don't need to go and build the whole HTTP layer. You can just plug in an
Right.
HTTP layer on top. So it's a really you end up kind of building these full stack applications by combining these blocks together, and you don't really have to think about how the network interface layer works potentially.
Interesting. And okay, so let's move on. So we have the embeddable PDPs gives us a faster response time. WASM has made this possible. And I would also posit for the third item that the basically the embeddable PDP requires less infrastructure. Assuming you have a PDP
Yes.
infrastructure, but in actually deploying out each instance of the PDP, if we're just giving developers a library, we're not telling them to deploy a sidecar or some other piece of infrastructure along with their code, which has always, in my experience, been tough. I know in the
Mm.
SSO space, like before Federation, we had these agents, and getting people to run an agent, getting web developers to install an agent, and having to support them on the installation of that agent was a nightmare. It's part of like older tools like SiteMinder. Running the
Mhm.
centerpiece was no problem, but we had thousands of agents out there, and then that agent had an installation process for Windows and Unix, or Linux or Solaris or whatever, and then Windows version would go from this version to that version. Now our agents would be like
Yeah.
out of sync, and we'd have to update them, and it created a huge amount of work. The infrastructure seems like nothing, but actually it was a lot of work maintaining, because these things, if we're going to say these PDPs run at the edge, if we are putting this infrastructure requirement on the edge, it can be quite a big impact.
And that's for the cases where at least there is infrastructure or there's a team that knows how to deploy into that infrastructure. We're now in a world now where there are businesses out there that don't run the whole infrastructure stack. You can go and take a much more like a managed type offering, and you are essentially just deploying code up. Where that code runs and how it's evaluated is you don't have to worry about it. It's kind of managed for you in that sense. Go and look at the Vercels of the world. Go and look at what Cloudflare is doing with Cloudflare Workers. Go and look at even Fly.io to a certain extent. Um, if you don't want to, you don't necessarily have to think about infrastructure. But then if there's a capability you want that does suddenly require running a Docker container somewhere, you then end up in a bit of a bind. So having kind of that escape hatch or having that alternate option where it's all embedded inside the application code that you can go and deploy just removes a whole world of complexity that you may not want to approach yet because of the stage where you are in your business, or you may never want to touch because you just don't want to move to that model. It really depends on how you're set up and how you're architected. But it's all about really flexibility, because once you have that embedded PDP, it can run essentially anywhere.
Okay, so now we've laid out 3 good reasons to use an embeddable PDP. Speed, easier infrastructure, and the using WASM WebAssembly. So let's talk about like the 3 objections that we get at proposing the solution. I'll start with the one that I get almost every conversation. I always get somebody who says, we couldn't possibly run a policy decision point at the edge because it wouldn't be able to connect to the database to get that critical information it needs to make a decision. And I'll give a use case. Let's say there's a policy that the server can send a notice only if the engineer is on call. So we need to find out, is that guy on call so we need to, call some API or whatever. So I'm just giving this a use case because I think actually most of a great percentage of the policies don't actually need this connectivity, but there are policies out there. What do you say to people who say that we couldn't possibly run a PDP unless it's connected to a database or API infrastructure to gather more data?
Yeah, so this really goes into the world of stateless or stateful policy decision points and the whole PDP versus PIP versus PEP type sort of discussion. So our Cerbos, at least, our view is that policy decision points should be stateless. Architecturally, the idea of having this policy engine which can start making arbitrary calls out to other parts of your system, or a PIP that can make arbitrary calls out to other parts of your system, is one that scares me a bit, because what may seem like a very small policy change could actually result in completely unexpected load to other parts of your system if it suddenly needs to aggregate state. And particularly when you think about authorization being in the critical part of every request, if you're having your PDP call out to go and fetch from state somewhere, that means that whatever system is calling needs to be scaled, potentially, if you haven't got any caching in place, to the same level of the actual application layer. So if you're doing authorization at a high throughput API, wherever it's going off to fetch state on the back end to go and make its decision also needs to be scaled to that same level. And it may be a system that isn't designed for that or can't be scaled that way. By moving essentially that concern up to either the enrichment of the tokens or the calling application, or the method call to go and do the permission check, the application layer, at least in my view, has a much better idea really of where that state is, how to fetch it, how to cache it, more importantly, sensibly, rather than actually caching an authorization decision, caching some of the inputs where it needs to be. It is a trade-off, though. Your developers are going to potentially have to go and do some fetching themselves before passing data along, but it does keep the decision points out of things, the policies, very clean and very deterministic and very, I can't think of the word now, very predictable in how they'll behave, because there's not suddenly this unbounded call over the network to go and fetch something to make a decision. You can make a decision based on the context it's given straight away.
Yeah, and you said something about that's interesting, is because my take on this is that nothing stops the application from calling an API to find out if the developer is on call or not, and then submitting that into the policy. Just saying, well, if this is a piece of data that you need to make the decision, you need to fetch it and then feed it into the decision.
Yeah.
So I think you could actually handle that. We're just saying we don't want the PDP to fetch that data. If you need that data to make the decision, you fetch it. I guess I'll say one other thing here, which is that um, we're not in a world where we have to have one PDP like architecture.
No,
Um,
absolutely.
in the world of databases, we have NoSQL databases, we have SQL databases, we have time series databases. There's all these different applications or infrastructures for returning data. And I feel like in the policy decision point world, there'll also be multiple architectures because
Yes.
maybe you will have a PDP running in the cloud, maybe a graph-based PDP that's Zanzibar-based that does
Mhm.
actually need to call an RDBMS. My question though is like, what's the overlap? When I think about what applications do most of the time, I believe that most of the policies that they can evaluate, probably they can evaluate with the information they have at hand. And I
Mm.
wonder, and I don't think there's an answer for this, but I wonder what percentage of those policies are we talking about? Where are we letting the corner case like rule like the general case for application developers?
Yeah, you're right in saying that. I think most of the time, either the application knows how to get it, or a lot of the time, the context required to make a decision is actually already available in like the scope of the request. So, for example, if you wanted to go and determine someone's roles or maybe claims, well, you're already going to have the token as part of the request, most likely anyway, and thus you can pass that on. Or the actual resource someone's trying to interact with, well, you're going to have to query the resource from the database anyway to go and mutate it if the action's allowed. So, your application is the owner of that resource and that object, so it knows how best to retrieve and where to store it, etc., etc. So there is a bit of fetching of data aggregation going on before passing it on. I think where maybe it does become a bit of a challenge is if you're in a truly sort of decoupled domain-driven design where one fiefdom doesn't know about the other fiefdom at all, then it does potentially get a bit different. If you do like event sourcing, for example,
Mhm.
how do you aggregate that state? And then even that, there's models where you can basically put a facade on top of a stateless PDP that knows how to do the aggregation if needed, um, but only for those edge cases, like you said, where it truly is needed, because it's going to be a trade off, like everything else in software, for what makes most sense for not only your architecture but the actual specific use case you're trying to authorize as well.
Yeah, it's an interesting example you give about where you have one domain which maybe has data that another domain doesn't have
Mm.
access to. However, I know you're aligned with this idea. Nothing. One of the misconceptions I see is that we need one PDP with all the policies. So maybe we have one. Let's just say we have a database, and that database has policies. Like maybe some of that data is confidential.
Mhm.
Um, and the application developer doesn't even know there's confidential data in there. So, but you have a set of policies for the application and you have a set of policies for the database, and those are different policy sets. So I think that, sometimes this idea of cross-domain policies is really not an issue because the if we have a different PDP with different policies and different pieces of architecture, maybe they're more likely to have the access to the data that they need.
Yeah, absolutely. And making sure you go and pick a policy framework, policy language, probably model that allows you to share common definitions where need be, but then
Hmm.
have domain specific policies in each of your PDPs. And in some cases, you can use the embedded PDP in a couple of domains, or you may want to use the full blown sort of service level service container Dockerized binary type PDP in another domain, depending on kind of what's going on. There's nothing that says you can't use both. We use specialized tools for specialized jobs all the time, um, and then pick what's best ultimately. And hybrid is also a completely acceptable way of approaching these things.
Right. Or even if you have all one type of PDP, each of those PDPs have their own distinct policy
Yep.
sets. And so, but yeah, potentially you could have a heterogeneous PDP environment, which is probably very realistic at enterprises who have they have one of everything. So
Oh
it's like,
yes, and the rest.
yeah. So I don't know. I find this criticism of not having a PDP, um, and it leads into my second objection, which is when people say, okay, well, we could get this done with tokens. If I could just mint these tokens and send them in, but we can't change how Okta mints tokens, or we have trouble enriching the tokens and putting the information in that we need. And so we need the workaround of calling the bases, the databases or the sources.
Mm.
Um, but in my opinion, so the objection that people have is we would need to get better at enriching tokens and enriching JWTs. And my answer to that is just yes.
Yeah, it sounds like a
But
perfectly reasonable ask of your IDP.
yeah, yeah. As an IDP vendor who spends a lot of time helping customers enrich JWTs, I just see JWT enrichment as a core capability of an enterprise, like the ability to put the claims that you need into the access token or the ID token in the right format that they're consumable by the application or by the policies. I just see that as the table stakes for being an IDP. But with
And you
that, I
can do
guess,
you can use a PDP at the token minting time to determine which claims or which value should go to the token anyway. So you can have PDPs all the
yes.
way down.
Right, right. Going back to my previous point about having distributed PDPs, yeah, it's essential that you know when we're talking about we're going to mint a token with certain scopes, those scopes are determining the extent of access. So there's a direct mapping to the claims that we're issuing to policy. So we absolutely need the IDP must have access to the policy infrastructure. It'd be crazy for the IDP not to have access to the policy infrastructure. It's one of the reasons we work on the Java binding for the Cedarling. So the IDP is still Java and it's going to be Java forever. But
Don't fancy a rewrite.
yeah, so I don't know. What are your thoughts as somebody who's not an IDP vendor? Is it too much of an ask? Are we asking too much of enterprises to get better at minting JWTs and enriching the tokens?
Well, with a specifically a stateless policy decision point engine, whatever mechanism can give us the most state or the state we need should come from the source of truth. So information about your principal, your subject, the source of truth in my view is your IDP. Maybe that's extended or got further attributes, maybe in a directory, or you'll have some other data source somewhere. But bringing the state to the PDP in the easiest way possible, particularly for the developer that has to implement the checks, is always going to be better. So making sure that you can start minting tokens, be it from an IDP or maybe
Oh
some other
no,
source that you're using, to get the permissions, to get the token, and then have that token pass through and then used inside your policies is always, I think, in my view, going to be better, because you're not then having to replicate state or information about your users or your identities into your authorization layer. Like, that feels like an anti-pattern to me. If you have to synchronize state anywhere, it should stay in a source of truth, and it should be transported on something that's structured, verifiable, and sort of standardized through the application layer.
right. So the identity provider is already connected to those backend databases. It can call IDPs. It's already expected to be pretty slow. You know that when you make that network request for the token, and you are talking about milliseconds. So we are, I think, aggregating data from the enterprise and stuffing it in the token is not a bad time to do that. Hopefully, it'll be reusable too. You're doing it one
Yeah.
time, but it could be input to multiple policy.
Yeah, I guess the counterpoint and thing to be wary of before everyone starts getting crazy and start minting tokens is token bloat is a real problem. It is a real concern, particularly at the web layer. If you ever tried to build up a massive JWT, loads of claims, and stick it in a authorization header, and then have your gateway or have your server reject the request because the headers are too big, that's a real concern. So don't stuff the world into a token. You're going to have problems, but be sensible. Like,
Right.
what is the key information here? Pass around.
Eli Nesterov from Spiral made that point in a couple of episodes back, and it is a good one. I'd just like to make a clarification here. If you're talking about an access token, and you are putting the access token into the authorization header, there are infrastructure constraints on how big those headers can be,
Yep.
and so really bloat that token at your own risk, man, because bad things could happen and it could send you down a really bad debugging hole that could take you
Oh
days to
yes.
figure out. So however, all tokens are not stuffed into the authorization header. Sometimes they're delivered in a response and they can
Yeah.
be quite large. And so that token bloat concern is a real one, but only as it pertains to access token being stuffed into the headers. For example, the JWT status list token Um, if you're talking about a really, really large IDP, it might be big. Um, but as long as the response can handle that and the client can handle it, it's not necessarily a problem. It could be valuable information.
Mhm.
Um, so yeah, it's interesting. My contention is that we need to get better at issuing tokens, and that there's a lot of different types of tokens that we're seeing. Um, Whereas the ID token is about a person, we also have tokens about workloads now, because
Mhm.
the software acting on our behalf is a lot of times the policies are about those workloads. So can this piece of software call this API? I don't care who's using it. If it's a third party application, it's not calling my bank API unless I publish this piece of software to the App Store, and we know that the checksum hasn't changed and it's running on a trusted device. So there's all sorts of parameters that might play into not just the person identity, but the workload identity. And the tokens that an IDP is issuing is not just about the person, but also about the software. And so, yeah, so
Yeah,
it's
and then
not
you go down the route of like FIDO attestations for devices as well. Like there's a whole plethora of useful context that you may want to use inside a policy, which can be passed around as tokens in some shape or form.
right. Yeah, I like that use case a lot. And that's really interesting for embedded, because a FIDO attestation is delivered to can be delivered to the application. So the application can use that FIDO attestation as input to data. For example, is this a shared key, like an iCloud keychain passkey, or is it a device-bound key, like a YubiKey?
Yeah.
So there could be policies that say, well, you can only do this thing if you're using a device-bound key, not a shared key. Um, and so, yeah, it sort of brings us into this. One of my ideas, and I don't know if this is a pro or a con, but one of the enablers for embeddable PDPs is the proliferation of JWT as a standard envelope for us to do
Mhm.
a lot of things, to put in FIDO attestations from the Google Integrity API, identity assertions. Now we have transaction tokens, which is an envelope for detailed transaction information. Um, but I guess any thoughts about what or why you think JWT has maybe changed the landscape a little bit for us?
Yeah. So standards always good, and it makes writing software easier if there are good standards to build upon. No, not all standards are created equal, to be fair, but I think JWT is one that has sort of stood the test of time for the last, I don't know, probably over a decade now. It's been a while since that idea was formed, and also how it's being adopted for other use cases beyond the traditional kind of user OAuth 2 type flow, like you mentioned, transaction tokens or FIDO attestations, etc. Um, Purely as well from like a introspection point of view, if you're trying to rationalize what's going on, it's much easier to read a JWT than a big certificate blob that doesn't really tell you anything besides it's a certificate and maybe it's chain. So I think it's got that nice two aspects in terms of their structured data that is readable, plus they're also verifiable, and there's now the ecosystem around it about revoking and managing those, and there's decent tooling in pretty much every language or framework you're using, including what can be compiled down to WASM to handle those. So I think the
Right.
standardization of the rest of the ecosystem that's adjacent to authorization is only going to make every component better and allows you to incrementally adopt these things without having to reinvent the wheel every single time.
Right. That's a really good point about extensibility. X509 certificates are harder to extend, to enrich, like I was talking about, to add extra data into. And just a quick pitch for Java, you could say, oh, we could do that with XML. We could sign
Yeah.
XML. But I have this theory that half the CVEs are actually related to XML parsing. So
Probably.
XML really wasn't a solution for us. So we needed a token. Now, um, standards don't tell you or will tell you what to put in that JWT envelope. But just the idea that we have this envelope that we can take a payload in JSON and sign it and pass it along was, I think, a key enabler for this embedded technology, because otherwise we have no way to really send the data from the center. To eliminate the PIP, we need some way to sign this data and send it in a trusted manner to the PDP. So I see JWT as a key enabler. Let me get to one more con, because I see we're bumping up against the time. We're just going to go over like a couple of minutes. I want to talk about the objection that people have that, okay, I used to have one PDP running on my VM, and now you're telling me that I have a PDP running in every browser and mobile app. So I have thousands or tens of thousands or millions of PDPs
Yeah.
running out there, each emitting logs, decision logs, each requiring a set of policies, each potentially, sending telemetry and other information. So any thoughts? Is that a challenge that we're maybe not up to facing?
Yeah. So how you get data streams back from very distributed and even potentially offline environments does become a real challenge. It does, if you look at a WASM, there are ways to make network calls, etc. But if you're now in, say, a mobile app, which could go offline, like how do you start caching those things locally, retrying, etc., etc., etc. So I think we're still quite early in the best practices around this right now. Like the way we do it with Cerbos, we basically expose a callback to the implementer saying, we will call this method or we'll call this function whenever a decision has been made and with the audit log decision. And then you can choose what to do with them. And we provide sort of transports for different backends that we support. But at this point, you can basically do what you want with the audit logs. How policies get distributed as well is also a bit of a tricky problem. These WASM modules, if you go with the WASM route, are kind of compiled static assets. But if you're changing your policies, how does that updated version of that static asset get pulled down to devices? Again, might have an intermittent connectivity issues. And there's all the fun, truly distributed compute type problems coming there. And the toolings and the frameworks are definitely coming along, and the technologies are coming along. Simple things of proper edge invocation of assets at the CDN level have been around for years, and that's a great foundation to build upon. But there are kind of still challenges today where if you're used to doing logging inside of your infrastructure in a certain way, you now need to adapt and say, okay, well, these logs are now going to come from client devices or edge infrastructure that isn't necessarily part of our in-house infrastructure. And it is a challenge, and I think everyone has to approach it in whatever makes sense for their stack. So I don't think there's a gold standard for it just yet.
Right. And this is where the vendors will differentiate a little bit on sort of the enterprise tools for managing this network of
Yeah.
PDPs. It's essential to deliver those policies with integrity, because if the hacker changed the policies, all bets are off on security. And so there's different levels of, I think, let's say, security requirements from the customers themselves about the integrity around the delivery of the policies. There's different levels of desire to consolidate the logs. So I think this is a real challenge, but I would just say that it's a challenge that we've been dealing with in other areas. It's not a unique challenge to PDP world.
Yeah.
And also, Open Policy Agent, which I mentioned before, is probably the most popular or the most downloaded of the new generation of PDPs, and they have also have the same challenge, because OPA running as a sidecar is still running distributed in the network. You still need to get those logs back. So this is a problem or a challenge, I think, for every vendor who's running distributed PDPs to figure out how to deliver. So real criticism, solvable, but also really valuable, the information that you get back from the edge. And this is the key advantage, I would say, in my opinion, is we basically didn't have eyes on the edge from a security perspective. And the PDP gives us a new level of like insight into what's happening at the edge from a security perspective. Maybe Alex, last point, and then we'll go to last thoughts on that.
Yeah, absolutely. Anywhere where you're making decisions, you want to be able to drive that by policy. It may be something as small as whether a button should be rendered or not, but if you centralize the logic behind that in policy, it gives you that flexibility, but also that centralized place to audit and review and govern the actual security posture behind your application, and is worth the effort, I think. Of course, I'm going to think that. But I believe in how you should start building and approaching your application at the edge, as well as what's running in-house, as it were.
Last thoughts, Alex? Action items?
Yeah, I mean, as you said at the top, looking forward to reviewing this conversation at Identiverse in a couple of months' time in the Las Vegas desert. But if you do want to get going and start playing with an embedded PDP, you can just head to cerbos.dev, create an account, and that gets you set up and start trying it out inside of your environments. And I'm always available to chat if anyone wants to go into a bit more detail. Find me on LinkedIn and the usual X and Twitter's locations.
Sometimes at IAW, sometimes at
EIC as well.
Conferences. EIC too. You'll be there.
Yeah.
Okay. So I'll just announce the next episode. We have another deep dive on passkeys. Should be interesting. And that's on Thursday. And another reminder, follow Identity office hours on LinkedIn. That helps us. It supports the show. And with that, I will say thank you, audience. Thank you, Alex. And we'll see you next time.
Thanks, everyone.